So for this question, we want to determine if x is in the span of y and z. So basically what we do is essentially it would set up this equation. Can we write x equals ay plus bz? Is there an a and b that makes this true? Well, this is basically the same thing as solving a system of equations. And we would do that by putting the y and the z into a matrix and then equal the x vector on the right. And then we basically are just seeing if this system of equations actually has a solution, right? It would be 2a minus b equals 2, negative a plus 2b equals 5, etc. So if we can solve this, we are good to go. So I'm going to start by swapping rows 1 and 2 to get my number 1 at the top there. I'm going to swap the other 2 rows at the same time just to put that 0 on the bottom where I want it. And then I'm going to use that 1 to eliminate things below it. So I'm going to add 2 of row 1 to row 2. That should give me 3 and 12. And add 5 of row 1 to row 3. So that would give me plus 10 and 5, 25, 28. And there's a little bit of a pattern here. We can actually see that all of rows 2, 3, and 4, these are actually just multiples. I've included the 0, be 0, 1 with 4. So if we just sort of reduce that, that would be the only thing left, and that could wipe out everything else. So negative 1, 2, 5. 0, 1, 4 if I divide that row by 3, and it's going to wipe out the other 2 rows. They don't all cancel with each other, and one of them has to be left over, but it's going to wipe out the other 2, and then we can just do a little bit more to reduce it a bit better. Negative 1, I'm going to subtract 2 of the second row, and then we get this, and we see this does have a solution. And I mean, I don't really know why I didn't do this sooner, but I suppose I could make that first row all positives just so it's a little easier to see the solution. But what we do get here is that I have, a equals 3. That's what the first line says. The second line says b equals 4. And so, yes, there is a solution. It's x equals 3y plus 4z. And so yeah, x is a linear combination. Or the same thing, a linear combination, or is in the span of y and z. In other words, it's a linear combination of y and z.